In this video, I'm going to look at acceleration. We're going to define acceleration, then look at the formula for acceleration and how to apply that formula. We'll then look at getting the acceleration from a velocity time graph, and we'll look at acceleration due to gravity and the instrument used to measure acceleration. So firstly, acceleration is the rate at which speed or velocity changes in a given time. Now, acceleration can be used interchangeably with speed and velocity, and it is measured in the units of meters per second per second. So when we write that, it's m/s/s. So meters per second, because it's the rate at which speed or velocity, which is measured in meters per second, changes in time. So you add an extra per second on the end. Negative acceleration is sometimes referred to as deceleration, and this is the rate at which an object slows down. So if an object is decreasing its speed or velocity, it has negative acceleration. So if we look at the acceleration of this rocket ship, if it starts from launch down here, when time is 0 and velocity is 0, if it has an acceleration of 50 meters per second, after 1 second, so when time equals 1 second, the velocity is going to be 50 meters per second. So we add 50 meters per second for that second. Then, in the next second, it's going to increase another 50 meters per second. So at time is 2 seconds, the velocity will be 100 meters per second. So then in the next second it accelerates another 50 meters and ends up at time 3 seconds having a velocity of 150 meters per second, and again another 50 meters per second added gives us 200 meters per second at time equals 4 seconds. So you can see that as having uniform acceleration means you just add that acceleration on for each velocity. Onto the velocity for each second. So the formula to find acceleration is the final velocity minus the initial velocity divided by the amount of time between the two velocities. And when we write this, and this is another confusing one, we actually use a equals v minus u on t, where a is the acceleration, v is the final velocity, and u is the initial velocity, and t is time. And this can be a little bit confusing, but as I've said before, in physics sometimes all the letters are taken, so we can't have, in this case, having two v's for velocity in initial and final, so we just change the initial velocity to u. What we're going to do now is apply the formula that we've just learned to the rocket example. So what we're looking for is the acceleration. So first we work out what we know. We know that at time equals 0, the velocity is 0, so the initial velocity is 0. And we know that at time equals 4 seconds, the velocity is 200 meters per second. So we know that the final velocity is 200 meters per second, and there's 4 seconds between these two velocities. So we use the formula A equals V minus U, where final velocity is 200 meters per second, initial velocity is 0 meters per second, and the time is 4 seconds. So 200 minus 0 divided by 4, or 200 divided by 4, which is 50 meters per second per second. And this makes sense. That's what we had in the example. So we proved that that was correct. Now I chose to use the t equals 0 and t equals 4. You don't need to do that. If I'd chosen, for example, to look at the t equals 4 and the t equals 2, we can see that going from 100 to 200, so the final velocity is 200 meters per second, initial velocity is 100 meters per second. There's 2 seconds in which that happens, so 100 divided by 2, 50 meters per second. So it doesn't matter where we measure this from, we're going to get the same thing because it's a constant acceleration. Okay. When we look at a speed time graph, similar to the distance time graph, and we could look at the gradient to find speed or velocity, on the speed time graph, we can look at the gradient to find acceleration. So this is the same graph that I used in the last video. And you can see that this gradient here is very steep. So it's very quickly accelerating from 0 meters per second to 2.4 meters per second. So we've got a quick acceleration here. We then have this flat point here where the speed stays at 0.4 meters per second. So it's neither increasing nor decreasing. And when we're not increasing or decreasing the speed, or traveling at a constant speed, there is no acceleration. So the acceleration in this part of the graph is 0. We then, at 15 seconds, get a very quick deceleration or negative acceleration. Then from 15 to 35, again, the speed is 0 for that. So there is no acceleration because it stays the same. Speed is constant. We then get an acceleration up to 0.2 meters per second. And then a constant speed, so no acceleration for the remainder of the time, up to the 45 seconds. So we can look at the gradient of the speed time graph and find the acceleration or deceleration. Now, gravity, which you've learned about in previous years, is a force that accelerates objects towards the Earth. And the amount of acceleration that gravity puts on an object is 9.8 meters per second. So if I were to jump off a cliff, I would accelerate at 9.8 meters per second. So after 1 second, I'd be traveling at 9.8 meters per second. After 10 seconds, I'd be traveling at 98 meters per second, and so on. And this acceleration, 9.8 meters per second, is referred to as 1g. So if we're talking about being on, say, a roller coaster ride that gives us 2g's of acceleration, that means I feel twice the acceleration that I normally feel for gravity. When we measure acceleration, we use an instrument called an accelerometer. Now, accelerometers these days are very, very cheap and very, very small, and they're put in a lot of electronics, and this is how a lot of electronics can work out the motion of what's happening. So you find an accelerometer in your Wii controllers, looking for the movement as well as the tilt, and in mobile phones. They're very common as well, and that's how you can play games on your mobile phone, where if you tilt it, you turn or whatever. So by tilting the phone or turning the phone, it picks that up in the accelerometer and changes whatever's happening in your game. In this video, we've looked at acceleration being the rate at which speed or velocity changes over time. We've talked about negative acceleration or deceleration, something slowing down. We've looked at the formula for acceleration, where acceleration equals final velocity minus initial velocity divided by time. We've looked at the velocity time graph and how you can, or a speed time graph, and how you can work out the acceleration by looking at the gradient of a speed time graph, where if the line is flat in the speed time graph, there is no acceleration. We've also looked at gravity being a force that accelerates objects towards the Earth at 9.8 meters per second, and an accelerometer as an instrument for measuring acceleration.